Hey everybody, day 3 of virtual learning. Looking at a new topic, the next step in this whole transformational geometry thing. And hopefully when you look at this picture, you've got to get a quick idea of which one this one is. And obviously we're looking at a reflection. So we've got a scene from nature here. We got the mountains being reflected on the water. And so this idea of reflection is the image is being flipped. But when you look at it, it still looks exactly the same. And what's close stays close, what's far away stays far away. And what I mean by that is, if I draw a line right here on this picture, right through the middle, very good line. But what's far away up here stayed far away down there. What's close in here stayed close in here. So that's the thing it was flipped on. Right? So we're going to keep coming back to this idea of what's close stays close, what's far away stays far away as we look at reflections. So before we do that and get into the math part, got a little activity here I want you to do. Try. So what we have here is that two pictures. Picture 2, which is on the right, is a reflection of picture number 1. So what I want you to do is you're going to pause the video in just a second, and I want you to figure out how many things are not reflected correctly. Right? So which things from picture 1 to picture 2 are not reflected correctly. So I want you to pause the video, try to figure out how many things are not reflected correctly, and then come back and I'll circle them for you. Alright, welcome back. So the things that are not reflected correctly is, first thing, you have the flower vase in the front. You have this MEP on the door. We have the clock, not reflected correctly. You have the lamp on the desk. You have the cup on the desk. You have the posters on the wall. And you have these little vase things. So those are the things that are not reflected correctly. So there is 1, 2, 3, 4, 5, 6, 7 things that are not reflected correctly in this image. And how can we tell they're not reflected? Because things should flip. So for example, if you just look at the flower is facing the exact same way. So what actually happened here was, we would call that a translation. So that was the things that happened the other day. So in reflections, we're looking for things to flip. And think about when you see a reflection. What do you look at? You look in a mirror. So essentially, a reflection is going to be a mirror image of an object. All right? So in math terms, what does a reflection do to an image? It's a mirror. Or sometimes you'll see it say flip. And if you remember, the word translation has that SL for slide. Well, reflection's got an FL, which can stand for flip. And what we say is a reflection is a transformation which flips the figure over a line. Right? And we call that line the line of reflection. And there we are. And so what we're going to do is we're going to focus on how do we find the line, what do we do, how do we reflect an object on the coordinate plane. Ready? So right here, I've got triangle ABC and I want it reflected over the x-axis. So draw the image ABC prime and let's take a look at it. So first thing I'm going to do is I'm going to write my coordinates. Alright, so my coordinates for A is 1, -3, B is 3, 0, and I have C at 4, -0. So when it says it wants to reflect over the x-axis, that's the first thing I'm going to do is I'm going to find the x-axis. So right here is my x-axis, and that means I'm going to flip it over. So that means it's going to head from the bottom to the top. So if it was on the top, it would go to the bottom. If it was on the bottom, it goes to the top. So all I do is I flip. And when I say what's close stays close, what's far away stays far away, what I mean is I'm going to count how many blocks away from the line of reflection point A is. And there's 1, 2, 3 blocks away. So that means on the other side, it has to be the same distance. 1, 2, 3, and that became a prime. Now point B is directly on the axis, so it's 0 blocks away. So I'm going to keep it at 0 blocks away, and point B is just going to stay become B prime. It doesn't go anywhere because it's on the axis. And finally, point C, 2 blocks away from my axis reflection, means on the other side it's got to be 2 blocks away. 1, 2. And now I can fill in my A, B, C prime. So if you're reflecting across the x-axis, that's going to be an up or down flip. So if it's at the top, it comes to the bottom. If it's at the bottom, it goes to the top. So let's look at our coordinates now. A changed from 1, -3 to 1, 3. And then we had B stayed exactly the same because it was on the axis. And C changed to 4, 2. Notice which coordinates change signs. Well, obviously this one didn't change at all. But that's what happens. So when you reflect over the, and I'll go over this again later. So when you reflect over the x-axis, the y-coordinate changes sign. So if it was a negative, it became a positive. If it was positive, it would become a negative. And we'll go back over this again. All right? So just know, x-axis, reflection, is a up-down flip. So up or down. So let's go on to the y-axis reflection. The first thing I'm going to do is I'm going to highlight my y-axis. There's my y-axis. And I'm writing the coordinates, same coordinates as before. 1, -3, 3, 0. And the last one is 4, -2. Once again, what's close stays close, what's far away stays far away. So this is my line of reflection, the y-axis running vertical. So now, how far is A from the y-axis? It's 1 space away. So that means on the other side it has to be 1 space away, A prime. B in this case is 3 away from the line of reflection. That means on the other side it has to be 3 away from my B prime. And C is 1, 2, 3, 4 away, 1, 2, 3, 4 away, and there's C prime. So, what would you say about this one? So, y-axis reflection actually becomes a left, right. And let's look at our coordinates. So, A prime is now located at -1, -3, -3, 0, and -4, -2. So, if you notice, what coordinate changed? It's the x. So, on a y-axis flip, you would look at it and say, okay, I have a change of the x-coordinate. Y stayed exactly the same. And we'll go over that again. Alright? So it's kind of an opposite thing. So just know for right now, if you go to the y-axis, it's a left-right flip. Alright, so now we're going to graph, and we're going to go over the x-axis. So 0, 2. There, 3, 4, so J, 3, 4, J, and we have L, 5, 1. Alright, and we're going to be going over the x-axis. So, I'll highlight the x-axis here. Alright, so because I know it's an x-axis flip, that means I know I'm going to be going up and down. And what's close stays close, far away stays far away. So I'll start with L here. L is 1 away from my line of reflection, so that means on the outside it has to be 1 away, L prime. K prime is 1, 2, 3, 4 away. 1, 2, 3, 4 away. K prime. And J prime is 2 away. I'm sorry, J is 2 away, so that means J prime has to be 2 away. But here's the thing. Even though these shapes are flipped, these things are always congruent. And congruent means same size and same angles. So notice congruent does not care about direction at all. It doesn't care if it's facing left, facing right, where it is located. All it cares about are the side lengths the same, are those angles the same. If those two things are the same, you got a congruent shape. So let's do our coordinates real quick. So I know if I go over the x-axis, my y-coordinate's switched. So 0, 2, so 0 wouldn't change, but 2 would now become negative. 3 wouldn't change, but 4 became negative. 5 wouldn't change, but the 1 now becomes negative. And I can see that's what happened on my graph. Alright, so now we got to figure out, what if we have a reflected image, and we got to decide, well, what was it reflected over? Well, we got to look and see how it traveled. So I look here and I say, okay, it's from left to right. Now I can tell this is a reflection, not a translation, because if I translated this thing, K would still have to be on the right side. And because K is no longer on the right side, I can tell that this thing's been flipped over. So what I have to do is I have to see, okay, I can tell it's been flipped left to right. I got to see how many blocks apart it is. Well, 2 blocks. So the line of reflection has to be halfway between them. So 2 divided by half, or half of 2, is 1 block. So that means 1 block away exists my line of reflection. Well, in this instance, my line of reflection is the y-axis. So we got to flip over the y-axis here. So find the halfway point between. Same way on this one. Now this is a little bit different. C to C prime, so it's definitely been flipped. I have a distance of 1, 2, 3, 4 blocks. 4 blocks. And this has been an up-down flip. So 4 blocks difference, half of 4 is 2. So that means 2 blocks away, 1, 2 is my line of reflection. Alright, 2 blocks away would be my line of reflection. Because it works. Remember, what's close stays close, what's far away stays far away. A prime is 2 blocks away, A is 2 blocks away. B, 1, 2, 3 blocks away, B on the other side is 3 blocks away. So whatever the distance is from the line of reflection on one side, it has to be the exact same distance on the other side. Alright? Alright, so we're going to reflect this one. So we're going over the x-axis again. So why don't you go ahead and pause, see what it looks like, see what you think it would look like, and then come back. Alright, so we're reflecting over the x-axis, so I'm drawing my line. I'm 1 away here, so that means on the other side I'm 1 away. 2 away, 1, 2. 2 away on that side, so it's C prime, F prime. C is 2 away, C is 2 away there. D is 1, 2, 1, 2, 3, 4 away, 1, 2, 3, 4 away, there's D prime. Connect my shape. And there I've just reflected that image over the y-axis. But there's more to this one. This one wants us to create polygon C, D, E, F double prime. It wants us to translate. So it wants us to go 3 to the left and up 2. So all we have to do now is take this new shape we make and we do a translation like we did the past couple days. So I'm going to go 3 left and up 2. And the only thing it asks about is C double prime. So that's really the only one I have to do. So 3 to the left and up 2. So I'm going to go 1, 2, 3 left, up 2. There's where C double prime would be living at. And C double prime is living at -3, 0. I mean, I can move them all. So 1, 2, 3, up 2. There's the F double prime. 1, 2, 3, up 2. E double prime. And B, 1, 2, 3, up 2. E double prime. So all I did was I reflected and then I translated. So there's 2 moves. Doesn't change how we do anything there. Alright, so let's look at this one. I want to reflect this image over the y axis. And go ahead, I'm going to highlight my y-axis here. So that means this thing's going to be a left-right flip. But the weird thing about it is my shape's laying right on the y-axis. So what's going to happen is it's going to flip on itself. So the same rules apply. What's close stays close, what's far away stays far away. So when I do this image, here's my line of reflection. I'm going to start with point A. And I just look, how far is point A from my line of reflection? There's 1, 2, 3 away on here on the left. So that means on the right, it has to be 3 away. 1, 2, 3. And that becomes A prime. B prime is 2 away here on the right, so that means it has to be 2 away on the left. Prime. C is 1 away, so that means it has to be 1 away on this side. And D, 1, 2, 3, 4, 1, 2, 3, 4, B prime. So if you have a shape laying directly on the axis that you're reflecting on, you still do the same rules. However far it is from the line of reflection, it has to be the same distance on the other side. The shape's just going to flip on itself. Alright, so don't feel like that's a major difference of how we do this. Still doing the exact same thing. As close stays close, as far away stays far away. Remember, the y-axis is a left-right flip. The x-axis becomes an up-down flip. Ready? So that's the first thing that you have to do is identify what kind of flips happen. You know, find your axis. Say, okay, there's the x-axis. That's going to be an up-down flip. There's my y-axis. That's a left-right flip. Alright, so let's look at these coordinates, what happens. So I've got this coordinate here, and it's currently living at 1, 2, 3, 4, 1, 2, 3, 4, 5. So it's currently living at 4, 5. And we're going to do the next y-axis flip. So I'm going to start with doing the the x-axis rotating flip first. So that means that's going to be an up-down rotating flip. So I got my line highlighted. It's 1, 2, 3, 4, 5 away. So that means on the other side has to be 1, 2, 3, 4, 5 away. And it now lives there at the coordinate 4, -5. So you'll notice what switched. So if you were flipped over the x-axis, what changed? The x-coordinate stayed exactly the same. The y-coordinate sort of signed. Right? So now let's go on to our y-axis reflection. Alright, so y-axis reflection, my green line. Alright, count how many away. I'm 4 away on this side. So that means on the other side, 1, 2, 3, 4. And that thing now lives at -4, 5. And you'll notice what coordinate changed. The y. I'm sorry, the x. The x coordinate changed. So here's my original coordinate. And that became -x positive y. So it's kind of an opposite thing that you have to watch out for. Just know that if you're flipping over the x-axis, the y changes. If you're flipping over the y-axis, the x changes. So we call that the algebraic notation. So if you want the algebraic notation of that, all you're doing is saying, okay, what would this look like without numbers? So the x-axis reflection, xy, y switch signs. The y-axis reflection, xy, the x switch signs. Alright? So just remember, when you're doing a reflection, as close stays close, as far away stays far away. Alright? Find your axis of reflection, find your line of reflection. Just like if you're looking in a mirror. You know, what's close to the mirror looks close, what's far away from the mirror looks far away. Alright? So that's kind of a quick little wrap up of reflections. So that's it, folks. Have a great day.